right, folks, ready to dive deep.
Always.
This time, we're going full-on hardware hacker mode.
Ooh, exciting. What's the target?
The Enabot SE.
Enabot, the pet camera that zips around.
The very one. Think Roomba, but with a camera and a direct line to your Wi-Fi.
Okay, starting to see the security concern.
Exactly. And our sources, these anonymous researchers, they get right to it. They want remote code execution.
No messing around then.
Nope. Straight into a teardown.
How'd that go?
Surprisingly smoothly. Quoting directly here, I didn't have to snap any plastic, and all the parts were easily detachable.
Well, that's both good design and slightly terrifying.
Double-edged sword, for sure. But hey, good for us, right?
Yeah.
Means they get to the firmware quickly.
How'd they snag it?
2 ways. First, the classic, intercepting the firmware update. Wireshark, network traffic, boom, they've got the update file.
Standard procedure.
Exactly. But then they get their hands dirty, literally. Dump the contents of the SPI flash chip.
Hardware skills. Nice.
They even give you the exact MIDI Pro command.
Sharing is caring, though maybe not if you're Enabot.
True enough. So, firmware acquired, time for analysis. What's the damage, or in this case, the potential damage?
Time for some digital forensics.
Out come the tools. Binwalk.tree. Turns out it's a Squash FS file system. User and root, they've got them both.
Interesting. What else is lurking in there?
A kernel. And wait for it, a BusyBox environment.
Handy.
With Telnet.
Even handier.
But no netcat.
Curiouser and curiouser.
Right. It's like, come on, guys, pick a lane. But speaking of choices, let's talk root password.
The gateway to all things juicy.
Exactly. And they find the password hash, right where you'd expect, etc. passed. But it's not the usual help me laziness. This one's recent. An 8-character beast. DES crypt hashed. They even calculated how long to brute force it, 5 years, with their hardware. Talk about dedication to, well, not so great security. So what do?
Don't keep us in suspense.
Crack Ash, $100, password cracked.
Yeah.
SC at 2019.
Practical. Though, it does make you wonder. Sometimes the weakest link isn't the tech, right? It's the humans.
Truth. But hey, they've got their password. Time to waltz right in.
Yeah.
SSH, they're in. They even share the PS command output just to prove it.
To show off, so what's next? Root around. Find that juicy firmware file.
They find it. EBOFWC.
Ominous.
Isn't it? But there's something else they spotted before digging in. Something about test pads on the back of the board.
Test pads. Think of them like potential debugging ports.
Like a secret backdoor.
Kind of? Might lead to JTAG debugging, even deeper access than SSH.
Now that's what I call a plot twist.
Indeed. So we've got firmware access, a potential secret passage, but the real journey is about to begin.
Because now they have to figure out how to speak this thing's language.
Reverse engineering time.
We're back, folks, and things are about to get seriously technical.
Buckle up.
Last we left off, our hackers, they're in, root access, but staring into a void of encrypted communication.
Time to break out the big guns. Reverse engineering time.
And they don't waste any time. Wireshark, of course, sniffing those packets.
What do they see?
All UDP.
Okay.
Seemingly all encrypted. But then, a clue. At the end of a packet, Charlie is.
Now that's interesting. You know what they say, right? Random strings are never random.
Never. What's the bet? It's an XOR key.
Gotta check.
They search the firmware. Charlie is. And boom, there it is.
Don't leave us hanging. What's it say?
Charlie is the designer of P2P.
Oh, yeah.
I mean, come on.
Not even trying to be subtle.
Right, so they Google it, just to be sure. XR encryption confirmed.
Told ya.
So, problem solved, right?
Yep.
Decrypt with Charlie, and we're home free.
If only it were that simple. Remember what we said about IoT security? Rarely that straightforward.
Yeah, so what's the catch?
They decrypt the data, and it's still gibberish. Scrambled.
Another layer.
Seems so. They actually found a descrambling function from another blog post. Real link cameras.
Nice. Borrowing from the community.
Always helpful. But even with that, no dice. Data's still scrambled.
Back to the drawing board.
Deeper. They break out GDB. Start stepping through the firmware's execution.
Getting into the weeds now.
Exactly. And that's where they have their aha moment. The descrambling, it was working.
It was.
The problem wasn't the scrambling, it's the protocol itself. This thing's a beast.
Complex.
Custom data structures, obfuscated code, no helpful comments, of course. This is where you need serious reverse engineering chops.
So what do? Give up.
Please. They're just getting started. They realize it's going to be manual packet analysis, firmware reversing, the whole 9 yards.
Talk about a grind.
But they've got the tools. Kaitai Struct, for those packet
And
structures.
to generate Wireshark dissectors. Don't forget those.
Right. And of course, Scapy for crafting packets, injecting them.
It's like they're speaking the machine's language now.
Almost. And they're not just using these tools off the shelf, they're modifying them. One of the team, Lane Third, forked the Kaitaita Wireshark project, added support for conditional statements.
Hardcore.
Hmm.
But this protocol, you said it yourself, a beast. They couldn't have dissected every packet
Yeah.
type, right?
No way. They got strategic, focused on specific functionalities. Started with motor control.
Makes sense. Start small, work your way up.
Exactly. So they find the motor packets pretty quickly, actually. 115 bytes long, very consistent.
Their first breadcrumb.
Precisely. Now the real detective work begins. They're analyzing the traffic, controlling the EBO with the app, matching actions to packets.
Trial and error.
Lots of it. But they're meticulous. They even share a snippet from the decompiled firmware. If mode something something not equal to 0aux D7 and mode something something equal to 0aux D8.
Mode something something. That's the technical term.
Hey, reverse engineering is an art, not a science. But those mode values, those were their Rosetta Stone.
How so?
By watching those values change when they press different buttons in the app, they started to crack the code.
The code of the motor, you mean?
Yep. And after a lot of trial and error, they got it. Turns out, those motor values, they were IE float numbers.
Who would have guessed?
Right. But they're on a roll now. They crack the audio encoding, figure out the video streaming, even start sending commands through Mavlink messages.
Hold on, Mavlink. Isn't that for drones?
It is, but it's also used in other robotics. And get this, the EBO. It had incomplete CRC checks for the Mavlink stuff. They actually had to fix a bug in the firmware before they could use those commands.
Talk about going above and beyond.
Right. But all of this, it's building towards the ultimate goal.
Finding that vulnerability.
And exploiting it.
And we're back. The moment of truth. They've got their tools. They've got their knowledge. Now it's time to break this Enabot wide open.
And they are not messing around. Get ready for not one, but two fuzzing attacks.
2. Going all out, huh?
Gotta be thorough. First up, they're using quailing.
Quilling. Okay, that one rings a bell. Emulation, right?
You got it. They're emulating the firmware's execution environment. But here's the kicker. They're not just randomly fuzzing the whole thing.
Smart. So what are they doing?
They took a snapshot.
A snapshot. Like
Yeah.
a picture.
Not quite. Think of it like they pause the code at a very specific point, right as it enters the packet parsing function.
Ah, so they're focusing on the most likely point of weakness.
Exactly. Then, with quilling, they replay that specific section over and over, each time feeding it different fuzz data.
Efficient. But emulating a whole system? Isn't that a pain?
Oh, you have no idea. They ran into all sorts of roadblocks, mallet calls acting weird, threading issues, you name it. They even had to borrow Unicorn's heap implementation just to work around some limitations.
Hacking the hacking tools. Sounds about right. But this is all behind the scenes, right?
Yeah.
Meanwhile, they've got Radamza unleashed on the actual device.
Oh, yeah. Radamsa, the dumb fuzzer, living up to its name, just hurling random data at the EBO.
Controlled chaos.
Exactly. But there's a method to the madness, I promise. They crafted those packets carefully, targeting different parts of the code. Maximize those chances of finding something good.
Right. But how do they know if they've hit pay dirt? Crashes happen.
True, but they had a system. After each fuzzing attempt, they'd ping the device. No response. Bingo. Crash.
Simple, but effective.
Right. So they're collecting these crashes, analyzing them, and,
Yeah.
well, a lot of them. Interesting, but not exploitable.
Dead ends.
What?
Frustrating.
Incredibly. One crash, though, out-of-bounds memory access, that got their hopes up.
Sounds promising. What went wrong?
Control. They couldn't control what data was being written to that out-of-bounds memory. Without that, it's just a crash, not a reliable exploit.
Back to the drawing board.
Back to fuzzing. And thankfully, because that's where things got really interesting,
You tell.
they noticed their fuzzer was changing the ebo.cfg file.
Hold on. The configuration file. But they're fuzzing their network communication. How's that even?
Right. It's wild, isn't it? Turns out the device was using user-controllable data to update its own settings without proper sanitization or validation.
Fantastic security blunder.
Textbook.
Yeah.
And that gave them an idea. They focused on the server domain parameter.
Used during firmware updates. I'm seeing where this is going.
Oh, yeah. They figured if they could change that domain, they could redirect the update to their own server.
And serve up a nice malicious update.
Exactly. So they craft a Mavlink packet, the payload, designed to inject new lines into that config file. Server A bin domain equals 10.42.0.1 in ECC.
Elegant, right?
Beautifully simple. So they tricked the EBO into calling the wrong number, but how did they actually get it to run their code?
They found not one, but two command injection points.
Two. That's impressive.
Right. One was during the URL parsing for the update, expected. But the other, the MD5 checksum validation.
Wait, they're injecting commands into the checksum? How is that even...
Mind-blowing, right? They realized they could craft the file names in a very specific way. Semicolons, special characters, all perfectly placed, so that when the device tried to calculate the checksum.bam command injection,
And they're in.
like burglars with a key, they even shared the file name. A file name file, NCO 10.42.0.11234, each hacked out in tar.
Artful. But it's a reverse shell, right? Temporary. What happens when the EBO reboots? But they thought of that too. Remember that SquashFS file system? They unpacked it, modified the startup script, repacked it, flashed it back onto the device.
Persistence, game over.
Game, set, match. They had complete control. The camera, the microphone, the movement, all theirs.
So did they contact Enabot? Let them know about this.
They tried, but no response. So they did the responsible thing, submitted a CVE, made sure it's documented.
Good on them.
Right. It's a wild story, isn't it? A real testament to their skills.
And a reminder to all of us, really. Just because something's cute doesn't mean it's harmless.
Exactly. Always be questioning, always be learning. And that's our show for today, folks. Until next time, keep diving deep.